Is Mohan Singh from AWS. And first off, I want to thank Conference42 for the opportunity to be here today. In this talk, we're going to explore how AI first platforms are reshaping MLOps, moving from manual, reactive operations to autonomous, self healing, and continuously improving systems. By the end of this session, you'll have a clear understanding of the building blocks behind self healing infrastructure, intelligent scaling, and autonomous code modernization. Let's take a step back and look at how MLOps has evolved. In the early days, it was very manual. Engineers were literally on call at 2 a.m., trying to put out fires whenever a pipeline broke. It was stressful, reactive work. Then came automation. It helped a lot. Workflows were faster, errors were reduced, but it still needed constant human supervision. Now we're entering something new: autonomous MLOps. Systems that learn, adapt, and fix themselves. No more 2 a.m. wake up calls, no more firefighting. That's the real game changer. So the question is, how do we get there? I like to break it down into three pillars, which we'll explore next. The three pillars of autonomous MLOps. First pillar is self-healing infrastructure, systems that can detect issues and fix themselves. The second is intelligent scaling, anticipating demand and scaling proactively. And the third is automated code modernization, systems that continuously evolve through AI-driven refactoring and patching. Think of this like a human immune system: detect, respond, and adapt to new threats. Let's dive deeper into the first pillar: self healing infrastructure. A self healing system that has four key parts: monitoring, that uses ML to spot anomalies; diagnosis, that pinpoints root causes across logs and signals; resolution, with automated playbooks; and a feedback that makes the system smarter at every incident. It's like an autopilot in airplanes. It doesn't just alert the pilot, it stabilizes the system immediately. Real world use cases: observability driven AI that detects subtle deviations, cross service intelligence that understands dependencies, and automated patching where systems fix vulnerabilities themselves. The results speak themselves for themselves. MTTR reduced by 90% and up to 80% of routine operations eliminated. Once infrastructure heals itself, the next step is scaling intelligently. So, how do we actually implement self healing systems? It starts with observability driven AI, tools that don't just monitor, but actively detect subtle deviations before they become incidents. Next, cross service intelligence, systems that understand dependencies across services, not just within box. That means failures are diagnosed in context, not in isolation. And finally, automated patching, infrastructure that can find and fix vulnerabilities on its own without waiting for human intervention. The results are powerful, and we see recovery times reduced by almost 60% and as much as 55% of routine operation tasks eliminated. Once your infrastructure can heal itself, the natural step is to make it scale intelligently. Traditional auto scaling is reactive. It waits until demand spikes before responding. That's like slamming on the brakes after you've already run the red light. It works, but it's late and inefficient. With predictive resource management, we flip the model. Using analytics and machine learning, system forecast demand hours or even days ahead. This allows resources to be provisioned proactively and, just as importantly, scaled down when they are no longer needed. The impact is clear: better performance, lower costs, and resources aligned with business priorities, not just technical triggers. So, how does predictive scaling actually work? It follows five steps: collect telemetry, not just CPU or memory, but also request patterns and business metrics; analyze with ML or AI, time series models, uncover cycles, correlations, even seasonality; forecast the demand, produce predictions from the next few minutes to several days out; plan resources, turning forecasts into precise allocation strategies; automation or automate the execution using infrastructure as code and feedback loops to scale in real time. It's a closed loop system that gets smarter with every operation, ensuring resources are always aligned with the demand. Now let's shift to the third pillar: AI driven code evolution. Think of your code base not as something static, but as a living system. With AI, code can now self optimize, self secure, and self adapt. This means automatic refactoring for performance, proactive patching before vulnerabilities are exploited, or continuous adoption of emerging best practices, all without waiting for manual intervention. This is powered by large language models, advanced code analysis, and reinforcement learning. Instead of developers constantly chasing technical debt, the system reduces on its own, allowing teams to focus on innovation. At AWS, my team used to spend around 30% of the time in cleaning migration related tech debt itself. So how do we actually modernize code architecture? There are three main approaches. First, performance optimization. AI detects bottlenecks, applies fixes, and even validates improvements through A/B testing. Second, dependency management. Autonomous systems assess risk in libraries, flag issues, and perform safe upgrades without waiting for patch cycles. And third, architecture evolution. ML-powered tools recommended and sometimes implement structural improvements as systems grow. The payoff is huge. Like we have seen 90% fewer vulnerabilities, 30 to 50% performance gains, and a 30% dramatic reduction in maintenance overhead for just my team. So, what's the real business impact of autonomous MLOps? Organizations adopting the systems have seen operational overhead cut by 75%, recovery times reduced by almost 90%, and infrastructure costs lowered by around 35%. These aren't small incremental gains. They're function improvements, unlocking efficiencies, reliabilities, and agility all at once. That's why autonomous MLOps isn't just a technical evolution, it's a business transformation. The journey to autonomy doesn't happen overnight. It's phased progression, usually over 18 to 36 months. Phase one is foundation, get observability in place, and standardize infrastructure as code. Without good telemetry, autonomy cannot work. Phase two is augmentation, layer in AI powered monitoring, anomaly detection, and early predictive scaling, often with human oversight. Phase three is autonomy, system start handling, remediation, and predictive scaling with minimal intervention, plus early code optimization. Phase four is evolution, self improving systems that adapt architecture through reinforcement learning. The key point is that each phase delivers measurable value on its own, so the benefits start well before full autonomy is reached. Now, looking ahead, several trends will push autonomous MLOps even further. First, multi-agent systems. Instead of one AI making decisions, multiple agents collaborate to manage infrastructure dynamic. Second, explainable AI operations or XAI ops, bringing transparency and accountability to autonomous decisions. Third, cross platform optimization, AI that can seamlessly shift and optimize workloads across hybrid and multi cloud environments. And finally, continuous learning infrastructure, systems that don't just learn from local incidents, but from global patterns across industries. The takeaway, self healing, intelligent scaling, and code modernization are only the beginning. What's coming is fully autonomous cloud ecosystems. To wrap up, thank you all for joining me on this journey into autonomous ML. I hope this talk gives you the vision of what's possible and a roadmap to start your own journey towards autonomy. I'd love to hear the conversation, so please feel free to reach out to me. Thank you.